So this is going to be a collaboration between BP, Quest Labs, and Dynamic Graphics. Some introductions. My name's Tim Hunter-Rowe. I work in the technology division of BP, delivering wells and subsurface data platforms. I'm also joined by the relaxing Carl Godkin from Dynamic Graphics, and also Ryan Jarvis from Rock Energy. Rock will be representing Quest Labs during this presentation. Two other notable faces, very notable faces on this slide, who couldn't be here today. Rakesh, who's the CEO of Quest Labs. They produce the Alloy software that we'll be talking about. And also Andy Kerr from BP, who's been spearheading the data quality initiative in BP for the last couple of years. Particular thanks to Andy as well for creating this slide deck. Okie dokie. So to set the stage then, I'll kick off with a look at the vision and business outcomes. So why are we doing this in BP? Then I'll hand over to Ryan, who will talk through some of the technology, platforms, toolkits that we're employing. He'll then hand back to me, and I'll talk a little bit about how we've implemented that within BP, what framework we've put in place. And then we're all building, Ryan and I are a support act for Carl, who's going to take us through a demo and show what this all looks like when it comes to life using Coviz and demonstrate some business workflows. If we have time at the end, I'll have a look at a couple of data management screens. So I'll start on the right-hand side. I'm sure this is a challenge many are aware of from our geoscientists and our engineers. They want two things. They want to find the data efficiently, and when they find it, they want to be able to trust it. So this is a challenge we had in BP, and we've approached this through three main pillars. First thing we wanted was a consistent set, and this is important, of SME-approved data quality rules defined against an industry standard, in this case, obviously, OSDU. We wanted to centralize these, so decouple them from some of the proprietary systems that we have. In the same way OSDU is breaking down data silos, we also want to break down, obviously, the data quality silos. And then the third thing is that if we want to do data quality, we know that we need to integrate it systematically within our current processes and ways of working. We can't expect our users to step out of their workflow to do data quality because it's probably not going to happen. So we need to integrate it into our existing ways of working. On the bottom there is a sort of a delivery map, if you like. The point here is to demonstrate this isn't just a case of buying some software and installing it and we're done. This is a culmination of many constituent parts that we've put together. So technology is very important. We also need a robust implementation framework for that technology, and we need to wrap it in some business process and governance if it's going to work properly. So I'll hand you over to Ryan.
Great. Thank you so much, Tim. This is exciting work for the industry. It's incredible to be here today. Really appreciate the opportunity to be here, with DGI and with BP. And why do we want to use OSDU for this? Now, OSDU is the trusted data foundation. It's the platform capability that you see here at the very beginning of this chain to deliver value for BP. Now, OSDU is, it's a standard for where the industry is storing data and metadata in the cloud and on-prem, actually for all of our workflows and business decisions. Now, some of the metadata is actually pretty critical. We talked about it a little bit in the last one, but essentially, data quality, business rules, and technical assurance are some of the key metadata that we want to be able to capture. Now, using the well-known data schemas, we can actually capture some of the data quality results from our evaluating each of the data quality rules. And it standardizes the way that we implement, integrate, and report data quality. One of my favorite topics, technical assurance. So technical assurance builds user trust. It helps them because they can take it augments all the data quality results with a business context. And this business context comes in the form of a stamp with basically a trust level and a purpose. Those give us more confidence in how we make business decisions. So why Alloy? So BP actually uses Alloy in their production environment today. They have started a great venture to centralize their data governance, their data quality rules, and their business rules. Now, Alloy is it's a system basically that gives you kind of a data quality as a service, and it's provided kind of at a very, very scalable abilities, both on-prem and in the cloud. And although it was built to be OSDU native, it's actually not just for OSDU. It has the capability to connect to any corporate data repository and evaluate the data quality in using the same rules consistently. And this is important if you want to have centralized data governance of data quality. Now, I'm going to share with you just some of the top 10 highlights or capabilities that Alloy provides BP for their trusted data ecosystem. The first 4 are here on the slide. We've got prepackaged rule sets, complex custom rule sets, and conditional triggers and parameters. On the prepackaged rule sets, you get a lot of rules for free. Essentially, there are rule libraries that come out of the box so that you can instantly, basically, evaluate the data and the metadata. So it's not just the metadata, it's also the DDMS data with rules. And one of the great things about this is you can take those rules and leverage them across your whole enterprise, the same rules consistently. Now, it also allows you to have custom rule sets. Now, some of these can be quite complex and cross-kind, but there's an expression language that allows you to actually write your own custom rules. And finally, some of the conditional triggers are, you may have a well offshore or onshore, and you may want to have it execute a rule or not. So that's where we get the conditional triggers. And then parameters help us scale. So for basically using Alloy across multiple OSDU instances, we can use the same rules because the parameters for the namespace are there. You don't have to have different rules for different systems. So kind of on that lens. Now the next 3, we group rules together in QC profiles. Now these are pretty exciting because what you can do is you can create a QC profile for a specific purpose. And it's, one example might be data migration. You have a QC profile set of rules for your, before getting the data in, pre-ingestion. You also have another set of rules for post-ingestion. That can be quite handy. You can create a baseline QC profile for the minimum requirements. Some actually create profiles for applications and workflows. Each of these QC profiles you can configure with technical assurance. So it automatically is stamping with technical assurance the purpose of the data and the trust level. All of that combined with the results being stored back into OSDU. This is back into the community to be leveraged by all the applications and tools. This is the pinnacle of integration and interoperability. You can see here, this is a report, an internal BP data quality report that's actually pulling those results directly from OSDU. Finally, there are 3 capabilities that are really more about working with you in your workflows and your existing processes. So Alloy has some APIs and widgets that basically enable you to leverage this within your existing systems. So pre- and post-ingestion APIs, they are basically used by your applications and your data pipelines to get real-time evaluation of the data quality. So they can basically find out if there is a failure, and they can help you remediate that failure immediately. At BP, one of the great pipelines is the Databricks pipeline that they use Alloy to make sure that the data is good to go before it goes into OSDU. Additionally, they have applications that use the API to ensure that before the applications put it back into OSDU, like Halliburton and Schlumberger, it validates to make sure that the data is good. And in ways that are, referential integrity, that the manifests are proper, that they meet the proper natural key checks, all of that is done to ensure that that data is ready for OSDU. And we're going to be talking a little bit more later on about how CoViz actually used some of these APIs in the demo. But before we get there, I'm going to turn the time back over to Tim to talk some more about the implementation framework.
Thanks, Ryan. Yeah. Thank you. OK, so we've talked a little bit around the technology and how that works. This is the framework that we've put together to implement it within BP. In the middle there, you can see Alloy in blue. As Ryan said, this is where we create our data quality rules, where we group them into profiles, and then they're made available through APIs so we can use them wherever we want to. For instance, the gray box there, the data ingestion, migration pipelines, this might be where we're bulk loading data into OSDU from some of our legacy systems of record. We'll run some minimum data quality checks on there to make sure that it's suitable to be ingested into OSDU. On the right-hand side, in the green box, we've got end-user applications. When end users want to submit data into OSDU, we may run a slightly different set of data quality checks to make sure it's suitable for the particular workflow or environment that they've been working in. So that then comes into OSDU as well. And we don't stop there. As it says in the bottom, we continually reassess the data post-ingestion once it's in OSDU against a much wider number of data quality checks to continue to build that trust. We apply a technical assurance stamp to each record to stamp whether it's suitable or unsuitable. And all of that information is then stored back in OSDU using the open standards available to us. Why do we do this? So on the far right-hand side, what this means is when users go into their applications and they try and find data, we can filter it so they only find data that's suitable, the things that have passed the minimum data quality checks. And furthermore, they can then drill down into each of the data records that they're consuming to understand which data quality checks have been applied, whether it passed or not, whether there are any warnings, and so on and so on. All about building trust. On the left-hand side, for our data managers, because we've got a consistent set of open source data, data quality data, we can build dashboards and reports and things like this for particular assets or regions or disciplines, that kind of thing. OK, quick question. Who decides the data quality rules? Technology, IT, maybe some of the low-level stuff, perhaps. The best people to decide whether your geophysics data is good is the geophysicists, right? So we've built a whole load of business ownership and governance and process around that to include the business into defining the data quality rules. These are the actual processes and races here. We've got a process here which describes how a data quality rule is created, when it's changed, what triggers that change. These have all been agreed. We've got ownership and accountability RACI charts, so everybody understands what their accountabilities are with respect to data quality. I'm flying through this. This is a significant piece of work, by the way. Once we've got that established, we can then create our data quality rules in Alloy. Here's some screenshots. We've been doing that over the last few months. This is what it looks like. Once we've created the rules in Alloy, Ryan alluded to this earlier, generally we create 3 data quality profiles. So the gray one there is our baseline check, and this is essentially the same data quality checks that we see in the manifest ingestion workflow, but we've applied them through Alloy so we can use them through the API. Makes it more flexible. And these are the things that look at things like referential integrity, schema checks, that kind of low-level stuff. These are mandatory checks, by the way, so if they fail it, then it's deemed as unsuitable. On top of that, we put some more BP-specific pre-ingest checks. So these may be where we need data to comply to some internal search technology or analytics that we use within the company. So these are pre-ingest checks. After the data has been ingested, we then do a load of post-ingest checks, and these can be tens or even hundreds of data quality rules that get applied. These are not mandatory, these are advisory, as you can see there. The point of all of these tens or hundreds of post-ingest checks is we don't just want minimum data quality standard, we want to be moving to a gold standard, and this is how we're doing it. All right. So once we've run all of our data quality checks, we provide a technical assurance stamp to each data record. If it passes the mandatory rules, it's stamped as suitable for all workflows by a data quality analyst. In this case, the data quality analyst is Alloy. If it fails any of the mandatory rules, it's deemed as unsuitable for all workflows, and this triggers some work within our data management teams to sort of focus in on that data and understand why it's failing the ingest profiles. All right, so to summarize. For every record in ADME, we run some data quality checks, and we write the output from those data quality checks into the data quality work product component. Depending on the outcome of that, we will provide a technical assurance stamp back to the record and stamp it as either suitable or unsuitable. And the whole point of this is this piece. Why do we do this? We build trust with end users. End users can now find data and be confident it's suitable to use in the workflow that they're involved with. And, as I said earlier, they can actually drill down into each record and look at all of the data quality rules that have been run against it. Build trust. Where data fails the data quality checks, our data managers can focus their efforts. Yeah? Where are we seeing issues and problems as we try to ingest this data? They can focus their time more profitably. And then right on the bottom there, as I said earlier, because we have this data stored in a standard way in OSDU, we can create a consistent set of metrics and reporting and provide data quality reports against particular regions, assets, stakeholders, that kind of thing. So at this point, I hand over to Carl.
Okay. Can you drive?
I can drive.
Thank you. I have some notes so I don't forget to say all the important bits. Hello, I'm Carl from Dynamic Graphics. So let's see a demo highlighting some of the features we've discussed so far. We'll show how we can search for data considering technical assurance among the search criteria. We'll load some data into CoVis 4D, which is our software package, or one of our software packages. And just as a means of demonstrating some of the concepts we've discussed, we'll perform a simple V-shell calculation on a well log. After the calculation, we'll test if the resulting well log meets our quality standards using Alloy. And once we're happy, we'll load the calculated result back into OSDU, where Alloy will be used once again to measure data quality and stamp the new record with technical assurance information. To summarize our demo, and in fact our whole presentation, we're going to a good deal of effort here to make sure that the data we use in our workflows is of good quality. So you might have gotten that from everything I said so far.
Hopefully.
For this demo, we'll use some publicly available data from the Teapot Dome field in Wyoming. There are around 1,300 wells worth of data, all of which we've loaded into both of the forum's interoperability instances, if anybody's interested, see me after, for other members to play with. So it's open data, and it's all loaded up in a couple of instances for you to play with if you're interested. That's my advertisement. But for this demo, we've loaded 20 of these wells into an ADME instance at BP so that we can experiment with the workflows that we've talked about that consider data quality and technical assurance using Quest Labs Alloy tools. In addition, we'll record our work using the activity model and link the output well log back to the input using lineage assertion. So next slide, please, Tim. And play. Okay, the CoVis 4D application is capable of working with OSDU well data, reservoir data, and seismic data, but we'll confine ourselves to well data for this demo. Let's start, as every good OSDU demo does, by searching for some data. We'll narrow our search to the Powder River Basin and source field to RMOTC. Oh, getting ahead of myself here. Didn't take me that long to find it when I recorded this. Oh, cool. All right. Yeah, source field to be RMOTC, which is Rocky Mountain Oil Technology Center. As you can see, we can also, on the right there, add a technical assurance type to our search so that only records with their most recent technical assurance stamp matching the selected level would be found. So the search criteria has indeed found our 20 wells along with their well bores, trajectories, marker sets, and well logs. Let's discuss the well logs. So I'm moving through them here, different types. Here's well logs now. So various details of the metadata are pulled out into a table, including the technical assurance column here on the right. There it is. Looks like one of the well logs is stamped as unsuitable, which we should investigate. Fortunately, we have a button here to bring up the data quality report, which is now showing. Remember, the data quality is evaluated on ingestion in this system, so our well log records point to data quality records that were prepared by Alloy for use when making decisions. Anyway, we can see that there was a referential integrity problem, which has been not a big deal, but the point was that if you have problems in the data, you shouldn't use it or you should reconsider using it. Anyway, we're going to load all these data into CoVis, which is what's happening now. And we can see that we have the well logs in the context of a horizon, just a single horizon in this view. We have the well logs, some of them as lathe plots, some of them as log curves that you might be used to. We'll look at these well logs a few different ways and even make a histogram in a moment of the gamma ray curve. So we're playing around showing off the software here. Here's a histogram of gamma ray. It's going to appear in a moment. So there you go. But back to the job at hand. Didn't get my timing exactly right, did I? Anyway, back to the job at hand. Let's select one of the well logs and perform the volume of shale calculation on its gamma ray curve. So the More menu on the right, let's just select the V-shale calculation, which is about to happen. Remember, it's an elementary calculation we're just doing here to illustrate other points. We know how to do this. Everybody probably in this room knows how to do this. From there, we'll choose the gamma ray curve and the output log or curve name. And we'll push the Calculate button. As you can see, the Assess Data Quality button next to it has become available, so let's check the output. The pre-ingestion scan passed. So, since Alloy's happy, we can load it back in. And once that happens, Alloy does its post-ingestion scan on the record in the catalog and awards it the appropriate technical assurance stamp. So in a few moments after it's searched a few times here, this is real life in OSDU. Eventually, we'll see our new log. There it is. Let's look at the metadata for the new record. So we're going to do that in a moment. So I know you all love JSON. If we scroll down a bit, we'll find the V-shale curve that we just computed. And the record also contains a technical assurance record, the technical assurance stamp added by Alloy. And a little below that, we'll see a lineage assertion item that points back to the input well log. If we click on that, we're taken back to that metadata, the metadata for that well log, which we're about to do, and or any of these other blue lines become links to other reference data that you can have a look at. As you can see, the new well log is stamped suitable, and we can have a look at its data quality report to see what a winner it is. Finally, the V-shale calculation has been recorded using the activity model, so let's take a closer look at that. So this is the activity record, and this is where we can record the full details of any calculation. We get the inputs, the outputs, and if there were any parameters, we'd be showing them there. To finish up, let's add this V-shale log to the CoVis viewer, and now our subject well has a nice lathe plot showing the calculated volume of shale. Voila. Okay. Thank you for that. Tim, back to you.
Oh. Thanks, Carl. Awesome. Okay, so just to finish off, we've looked at the business workflows there through CoVis. Just a word, this is all, we use Teapot Dome data for obvious reasons, but all of that's in production. There was no mock-ups or anything there. That's all connecting to our production instance of OSDU in ADME, and it's pulling data back and forth. The only thing that we didn't do was obviously put our own data into it, but it's all up and running. So we did business workflow just to show a bit of love to data management. We'll finish off with a few screenshots. So these are some data quality reports that we've built based on the data quality information that Alloy has written into OSDU. So on the left there, you can see some data quality reports which you can drill down into. And on the right-hand side, these are some of the widgets available in Alloy that we can drop into our own tools and forms and things of that nature just to help accelerate the development of these. We don't have to start from scratch. There's already some pre-configured widgets that we can use. And then lastly, this is a data quality dashboard that the team have developed. On the left-hand side there, you can see sort of a heat map of data quality. We've taken off all of the sensitive bits, but you could do this per asset or per region or per discipline, however you wanted to do it. And on the right-hand side there, if you were to click on one of those boxes, you can drill in and see the actual output of the data quality report. So you can, if you've got an area that's maybe darker in there, which denotes lower quality, you can actually see what's causing that color to be made and where the fix needs to come. And I think that's us. Thank you very much. You got time? You got time for Q&A?
So we are running about 10 minutes behind. If I want consensus and I want to be fair to people, is there does someone have a burning question they'd like to ask? Please, Jacob, of course. And maybe we'll take one question, if that's okay with everybody. And as I say, I'm sure our colleagues are more than happy to take questions outside the room.
Thanks for the question. Thank you, Carl and Tim and Ryan. So I appreciate that very OSDU conformant using OSDU. You're storing the data quality results there. My understanding is that the rules themselves, though, are not yet in OSDU. However, I think there's an ongoing discussion with core concepts around the rules themselves and how to put the machine-readable rules in there. So I was just wondering, what do you think the value of that is, and how do you see that going into the future? When and if we do get those rules themselves actually in OSDU.
Do you want to take that one?
Sure, I can take this one. Thanks, Jacob. It's actually pretty special that we have a lot of standard rules. The way that they're being stored right now in OSDU is human readable, and it's not machine readable. So each of the rule evaluation engines kind of have their own way of interpreting what the human readable rule is and making a kind of a machine statement that's run in the background. We do have a work session right now within the core concepts group that I lead, where we're bringing in some of the main evaluation quality rule engines to come up with a standard specification that we can use in OSDU to store all of the data quality rules kind of in both the human readable but also in the machine readable. That way you can swap out any evaluation engine that you want. You can kind of benefit from any other evaluations from any other companies that use different evaluation engines on data. Hope that answers your question, but it's a good initiative.
All right. Thank you so much.
Thank you.
Please show your appreciation. Thank you.